Welcome, and gosh, it's always an adventure. So, my name is Vinnie Moscaritolo. I've been in the hardware business professionally for about 40 years now, and I think prior to that, I was in the 70s. I was kind of a homebrew guy, 8008 systems and stuff like that. Prior to the Altairs. So I've kind of had this in my blood. I worked for DEC. I worked for Apple. You might know names like PGP or Silent Circle and stuff, a bunch of startups. Process control stuff, network interfaces. I guess if you Google me, I'm kind of known for crypto stuff and privacy related stuff. A couple years back, maybe 2 years ago now, I'm thinking about it, I walked away from Silicon Valley and said, I'm done with these folks. They're all about censorship these days, and I was all about privacy. And so, I'm done with them. And what I do right now is I do search and rescue. I work for the local sheriff and do that kind of stuff. But I got time here to work on interesting projects. So everything I'm going to talk about, I either have on GitHub or Substack, and all that material is there for you guys to take apart and figure out and do whatever. So we live out here in Southern Oregon, and I would say this is even pre-COVID. We were kind of concerned about, doing our own food and doing our own. I mean, we're not survivalists or anything like that, but we were just being sensible. So in rural world, so one of the things we said is, hey, let's build a chicken coop. I've looked at folks had chicken coop designs where the door would open and close automatically. They would sell these boxes, and I'm sure I could spend $100 in a box, or I could build one for myself for $1,000 worth of investment. So I went off and said, let's go build a chicken coop box. And my first attempt at this, I worked out the hardware and built this thing with an 18 mega kind of Arduino sort of product, and quickly ran out of code, ran out of space. I ended up going with the SparkFun Artemis, and I hooked up in one of those ESP8266s to give me wireless to the thing, and wrote a bunch of software. Started off with a little simple command line interface that I put together so I could telnet into the box, and then tried to hook up some REST, HTTP kind of stuff to it, and then use an app. But it's frustrating with the ESP is that you can only do one port. Their AT-DT interface is just weak, and so I said, look, this is not a great design, but it does work. So let me show you a video first of. I'll move forward. Well, I'll do is I'll just tell you about the stories first, and then okay, I had that chicken coop working, and I said, oh, gosh, one of the other problems I need to solve is I've got a bunch of home automation, and I was using the Insteon parts, the outgrowth of the X10. This is before the Zigbee Z-Wave stuff, and gosh, there's software out there. There was a server that Indigo put together and runs on a Mac Mini, and it was not great. I figured I could do it better. I know there's a million home automation apps out there, but my first step was I wanted to get it off the Apple platform, off the Mac Mini. I'm trying to step away from those platforms. There's so much junk that comes with it that I don't really want that other stuff. I don't need to have an upgrade for the latest dancing emoji and stuff. It's just a home controller. So at the time, the Raspberry Pis were relatively cheap, and they were a great little Unix box. So I'm like, gosh, let's go out and build me my own little system. It can't be that complicated. So the real first Raspberry Pi project was I tried to build an Insteon server so that I could connect with a remote device and turn my lights on and off, or turn them on and off to schedule. And unfortunately, the Insteon protocol is not incredibly well documented. There's stuff out there, but you really do have to reverse engineer a lot of it. So it was fun. Got out there, got their USB device, and Wireshark the USB, and turned switches on and off, and saw what the protocol really, really looked like, and put together a Raspberry Pi system that had a RESTful interface, if you understand what I mean by that, over HTTP. And then I built an iPhone client. And one of the things, again, all of this is documented. On the Mac, there was this great utility called PAW, P-A-W, that is just incredibly useful for debugging REST packets. Anyhow, so I engineered the protocol and hooked up some really cool stuff like sunrise, sunset, and then wrote a Mac application. No, I'm sorry, an iPhone application. So, if I have my iPhone here, I've got this little Insteon thing, and I got pictures of. Gosh, it doesn't show up real well, but it looks like the control panel on my dashboard. The physical control panel. There's a bunch of little buttons here that you can turn lights on and off with, and scheduling and stuff. And so basically, this is just a client that talks to the REST. Then the next step, and I'll show you some video and we'll get deeper into it. But the next step was, I'm out here in Oregon. We've had a lot of, and I have problems with power coming in off the street. Unfortunately, where I'm located, I don't have good view of the sun. I'm on the north side of a hill, and so I need to come up with backup power. And so I can't just put solar panels up there. So one of the things I did is I said, let's come up with some backup power. And really what I want is that in the case of a fire, I want to be able to firefight. I want to be able to keep my grounds wet. And so what I did was I took the well pump and hooked it up to a cistern. So the well pumps into a big 2,000 gallon cistern. And that had a backup power supply to it. And that's pretty interesting stuff. I've got basically this giant inverter and a bunch of batteries, inverter charge controller. I've got these big old lead acid batteries because that's what was available at the time, thanks to supply chain issues. And I get this little Victron smart shunt that tells me what's going on. So the inverter and the smart shunt both have serial output. And so I put a Raspberry Pi in the pump house to monitor what's going on with the batteries and the inverter and the charger. So I can see like, gosh, do I have enough power? What's going on with that remotely, so I don't have to walk up the hill and turn on and off that stuff. And then the other issue was I need to know how much water is in the cistern. One of my problems in the summertime is because of all the growers, they're draining our water table. And so I need to know when to order water. Sometimes we've got to bring water in from a truck, and you could be 2 weeks lag time before you can get a truck up here. So I wanted to track how much water was in the cistern, what my usage was to just drive our gardens and our home. And so, I had to tackle that problem of like, well, how do you do that? Gosh, you can use, and I've seen people try to do ultrasonic where they beam into the tank and stuff, and that just doesn't work. So I came up with a pressure sensor, and they're these great little cheap things called TL231s, and they're basically a little 20 milliamp device. You submerge it in the tank, and it tells you, drains different current depending on how much water pressure you have. And you can go off and do the math and try to calculate how many gallons that is. Or a simpler thing to do is to just empty the tank or pull the thing out of the tank and then drop it to the bottom of the tank and look at what those two numbers are. And that gives you enough information to know like what a tank looks like. So there I did the same thing as the Insteon. I built a Raspberry Pi with a REST server, a bunch of software that talks those things. And I got a little iPhone client. Let's see if I can show you this really fast. And I have a little iPhone client that shows me the level of the tank and shows me what's going on with, shows me the level of the tank at the point, is stuff running, and what's going on with the batteries, what the temperatures are in there. And you can do a couple of things like actually track, let's see, oh, this is useful. Track how much, if I click on that, there's a little, this is not a great diagram right here, but there's a little picture of how much water is being used. It's hard to read on this screen, but you can see the tank filling up and dropping down. Okay. The other thing I want to show you is, let me just show you a quick video of taking a walk up there and looking at some of that hardware. And then I'll get into the other interesting projects here. So here I am. I did this yesterday because the weather was reasonable. This take about, what do I got here? About a couple minutes. And if you get audio.
Are we getting any audio on it?
Yeah, are you getting audio?
No, no.
Oh, nuts. How do we get audio here? Well, I'll talk about what it is. All right. So, but you have my audio.
Yes. Yeah.
All right. So this is the chicken coop. And what I have here is a door that I put on slides, basically drawer slides, something that you would find like that. And I have an accutator, and I hang the door with the accutator on wire. And the reason it's hung versus attached to it, and this is a lesson I learned, is that this way, when the door closes and if there's a chicken under it, you don't chop the chicken. I didn't actually have that happen, but I realized that the door was getting jammed up from all the hay at the bottom of the door, and so that kept the motor from breaking. So those kind of accutators you find in for cars, typically that's something somebody building a hot rod would use for opening a hood. And so the accutator is hooked up to this Raspberry Pi up here. Can you see my mouse? But there's a Raspberry Pi in the picture there, and a car battery that I use for backup, and a really cool little device that charges that battery. And the CPT thing is just a 12 volt to 5 volt converter. There's a couple of relays. And so what will happen is the Raspberry Pi will run automated. It'll run by itself. It knows when sunrise and sunset, and I have schedules that can be programmed in as to when to open and close the door. And also, and so there's an iPhone app, and just because you might manually want to do it, so you can press the open button or the close button. And so let's just see a quick example of it. So there I'm closing the door, and you can see that little accutator just drops down. I mean, it's simple design. And it's been those things come IP67, so that they can handle all the chicken poop and all the stuff that's flying in the air and all the dust. I got a couple of things I lay for a light. And and I have those buttons there. Those are cute little buttons that SparkFun makes that can light up. So when the door is opening and closing, you'll see a little bit of pulsing on the button. You'll see a little pulsing on the button while the door is in operation. There's a couple other switches that turn on the light so that I get better egg production in the morning. And I got another little device there for an electric fence because I've been having raccoon problems. I also have built it with a scheduling device where you can add in and say, hey, I want this event to happen at a certain time. And you could say, for example, 10 minutes after sunrise, or 10 minutes after, or a certain time after sunset, or something like that. And turn on this device or that device. So it's a great little app. And again, all this is open source. You can do whatever you want. So you can go in there and it's an iPhone app, but the fact is it's talking REST anyhow. So, and here it is. It calculates all the useful stuff, like, I have to give it my lat long to figure out what the sunrise sunset is. But once you've done that, it calculates all the sunrise sunsets automatically. And again, it's nice having the battery backup. So if I lose power, I still have a little bit of electrical stuff. Okay. What else can I tell you? Okay, walking down over into my pump house right here, you can see there's my pump house, and there's an inverter right here. Let's correct on that. so I have this giant, I mean, 6 kilowatt inverter to provide the AC, the 220 for the various pumps, because there's a pump to pump this from the well into the cistern, and there's another pump to pump the water pressure into a pressure tank, so I can have water pressure in the house. And the pump stuff is just standard relay pump stuff, but this tracks everything. And so if I come along and let's see if I can demonstrate this. Yeah, you can see there's a water tank right there. I'm pointing at one of the cables that goes down into the cistern that has a pressure sensor in it. And you can see there's the water right there. At the very bottom of that tank is got a pressure sensor. There's a Raspberry Pi, an enclosed thing. I don't have to battery back that up because it's on the inverter power. I battery backed it up initially, but then I realized, gosh, if that inverter power goes, it's a big deal. And okay, there's the picture of the holding, the app. And if I walk outside, let's just do that really fast. I'm demonstrating killing the power, and the inverter kicked in. There's another device that tells you the temperature. The only reason that's there is that inverter might get hot in the summertime if I'm running and I have a fan on the wall that will kick in and blow air. The fan up there will blow air out to cool off the room. Not that big a deal, but so what I have outside is I have a little box here that I built to hold batteries. Today you could do it with lithium ion, but this was during the whole supply chain problem with COVID. And, that's what I could find. In the best of all worlds, they'd be AGM batteries, but look, you got to go in there and put water in once in a while. Not a big deal. So that's the chicken coop project. The other thing, and I'll just do quick here, is so by the way, all this stuff is on Substack. I've written a bunch of stuff about that. I keep mentioning that I do REST, and I wrote like a whole bunch of articles about how you build a REST server and ways to debug it. And one of the things is that I'm not going over SSL right now. I'll get to that. My network is blocked off anyhow internally. Like there's enough firewalling in and out, and so I'm not so worried about somebody coming along and looking at my content. But one of the things that does happen is the REST packets that do things have to be authenticated. And so I've got this like SHA-1 6 HMAC that will authenticate the packets before you tell, like, for example, a chicken coop door to open and close, in case I get attacks from China that want to let my chickens out or something. I don't know. But you can do a lot of stuff with that. I'll get to doing the SSL stuff later. It wasn't, or TLS, it just wasn't a priority at the time. You would think a crypto guy would care, but in this case, it's not a big deal. The other project that I have going on is internally in my house. I have I'm connected over Starlink, and I happen to get one of the early betas of Starlink. So let me just show you this really fast and how the Raspberry Pis play in that. So I have this little server rack, and what's on the right-hand side down here is a Xantrex inverter charger thing, gizmo, and there's a car battery on the floor. And what that does is that's providing me enough power to drive my Raspberry Pis and my switches. I have a bunch of cameras out there. In fact, there's a Raspberry Pi that's running Xoma, Xeoma, Xoma. And that's an okay piece of software on a Raspberry Pi. It's not great. We could do better. But so what I have is I have the switches up here. All this is battery backed up. And I wrote an article about how to talk to this server using the Raspberry Pi Bluetooth Low Energy. I'm not a fan of this device. and here's I didn't mean that as a pun, but it had these really noisy fans, and it would come on and off every now and then. And so I ended up replacing the fans with some really low, quieter fans. That would kind of take that whole thing apart and throw away their warranty, but it's what I needed at the time. So moving on into this box here, there's a number of so right above the switches where all those Ethernet cables are, that second row of Ethernet cables, the yellow cable, is an array of Raspberry Pis. One of them talks to my Insteon server. One of them has one of these software radio SDA devices, RTL devices that will grab ADSB data from the planes flying by and crowdsource that ADSB data. And I also have one's running the camera, something to look at the cameras and tell me who's driving up and down into my driveway. I've had problems with drug dealers coming up into the driveway, and what's worse, the real estate people who look for equivalent real estate. They're actually worse. The drug dealers I could handle. And so I've used cameras to track who's going on. And there's another Raspberry Pi that acts as a NAS. It's not a great device, but the Raspberry Pi way up on the right, on the upper left-hand side there with the button, is a NAS. So let me just zoom in here and show you what I'm talking about, all these guys. Okay, yeah, you can see there's a whole array of Raspberry Pis racked up in there. And the box at the top is a little network device. And there's a little, where is the gizmo? Oh yeah, this is my home control. So what's interesting here is I wrote a part of the home control. So none of this is hard coded in the app. This is actually done on the server. That it's not even HTML. What the server does is the server, you can describe to it the protocol of what a keypad looks like and what buttons are in the keypad. And the app will draw the keypad based on the rest, the JSON that it gets back. And so, for example, this little keypad that you see right here is exactly the same keypad, let me zoom into it, that I have in the bedroom. And so they sync each other. So if I press one of those buttons, it syncs onto this app right here. You can also go and like manually flip switches on and off, or dim them. And one of the other things I did was if anybody builds anything like this, even if it's for Zigbee or Z-Wave, control the backlight. One of the things I find really frustrating at night is, and I'll just show this part, is those things are backlit and you see them all night long. So one of the tricks I can do is if I say lights out, the backlights will, let's see if I can just get up the timeout. So they just shut off. So that's kind of a useful thing. And that's a function with the, that's a function there with the server. So I built a chicken coop thing. I built the Insteon. I went back and said, gosh, the original chicken coop was great. But then I went back and did it as a Raspberry Pi. And this one happens to be an RPI 0. And it's got a relay controller and, like I said, motorcycle battery and a bunch of other stuff. The next project was, and this is the last part. This is a project I'm working on right now. This is kind of fun. I have this car. I have this Jeep, and I took the motor out of the Jeep and put in a Chevy LS, something you'd find in a Silverado, a 6.0, a more modern motor. And that left me with two different computers. That left me with one computer network that talks to the Jeep, and one computer network that talks to the Chevy motor. And but they use CAN bus, and there's a little device that goes across the two that will take, for example, information from the Chevrolet motor, like what the RPMs are, and feed it to the Jeep's cluster, moving the RPM meter. Well, since I'm looking at all that CAN data, I started saying, gosh, one of the things I want to solve is whenever there's a problem, rather than have to hook up one of these Autel boxes, these big gizmos to figure out, to look at the codes, these gizmos here to look at the codes. what I'll do is, why does the car radio do that? And the other problem is that because I'm in search and rescue, I have about 4 different radios I have to deal with, between the sheriff's department and SAR. So what I really would like is a better car radio. And so I thought, let's build our own radio. How hard can that be? So considering all this garbage I've done so far. So what I started building is a device that uses a Raspberry Pi. And eventually, let's see if I can show you this without yanking the power cord out. Oh, well, I don't know. Let's see. I'm going to hold it sideways. So, because I don't have enough, I'm going to run out of cables. So this is here a Raspberry Pi. They're showing a little volume control. A Raspberry Pi that, here we go, stacked up with a bunch of devices. It's got a CAN device on it to look at CAN. It's got some other stuff to do audio. I got the amplifier. I have an amplifier hidden in the bottom here, okay, to take the audio, and a vacuum fluorescent display. And when I get done with this thing, I'll fit it all in a car radio case. And my goal is to look at the CAN bus, pick up some information, for example, like when the car is going to come on. Because one of the things that you do is you see all this CAN traffic until the car shuts off. And at some point, it actually shuts down the vehicle. So, I have to work out all the technical stuff. So what I did was rather interesting. A lot of people have tried this business of how do I shut down a Raspberry Pi and kill the power and turn it back on again. And I've seen all kinds of crazy solutions. What I did was something kind of simple. I'll document this, but what I did was I took a relay that is, let's see if I can show you this. If I can lift the cable just enough. Yeah, maybe. So there's this little, hang on. What I got to do is move the wire closer. There's a relay that is okay, there it is. Now I can show you everything. This is cool because this is the current project. All right. Yeah, hey. All right. So what I got here is a little relay that is it's a latching relay that Hello was using for, and I guess they're in Mercedes for the glow plugs. And so, you power one side and it clicks to one direction, and you power the other side and it clicks the other direction, locks in. So what I can do is I've hooked up to the Raspberry Pi here. I'm going to hit the power off switch. And so it will, when the Raspberry Pi shuts down, I've got one of the pins, the GPIO pins programmed for shutdown, and it clicks the relay to shut it off. Then right now I just have a button that will turn it on. And so you hit that button and it automatically, clicks the relay, the Raspberry Pi will boot up, and like 20 seconds, right now, unfortunately 20 seconds, but 20 seconds later, the thing the VFD will come up and run the display. Really low cost. I mean, I found one of these things at Rock Auto for about $30, and you just need to take and drive the relay with a little bit of a couple of Darlingtons, and look, the clock came up, and it's kind of cool because that's going to be my car radio clock with a little volume control. So the way I'm doing for audio is I'm going to use one of these little RTL devices, software defined radio devices. There's so much stuff out there on that. And what you can do is code those things in to look at FM or look at AM. And in my particular case, I can look at you can write a police scanner, to scan the different frequencies when you're driving. So it can be a radio. And then since I've got the reason I'm doing the CAN is I want to be able to look at the trouble codes, but more importantly, I want to know when the vehicle's shut off. So I have another little AT mega device that one of those little tiny guys, it's here somewhere, that will look at, here we go. That will just look at the CAN bus and say, gosh, is there any voltage on that thing? Little guy, right? And what it'll do is it'll look at the CAN bus and we'll say, hey, is there any voltage on that thing? Since there's nothing going on right now, there's no activity. or if there is activity, turn it on, and I'll have the computer turn itself off. So, and there's a little 5 volt, 12 volt to 5 volt DC to DC converter. And so that's the current project right now. I'll document this also as much as I can, but lots of fun stuff to do with the Raspberry Pis. This car radio project, in all rights, I should probably put it in I should probably like 3D print a box for it. There's a couple of folks around here who do that, but I don't know enough about the CAD systems yet. And I do know that you can make metal from, you can get metal cut at, places like Send Cut Send, and they'll do like great stuff like that. But, I got to learn the CAD skill. But yeah, and that's that. So yeah, lots of fun stuff.
Well, you're certainly keeping busy, aren't you?
Yeah, and in the meantime, I'm also, we have a big county here, so I work search and rescue. I do mountaineering. I do the avalanche stuff, so that's snow work, and whatever else we end up doing in this part of the world. So yeah, I'm on call with search and rescue. So that, it's when you get time.
So what language is he using for all this? Is it all?
Yeah. Okay. Good question. Most of it's C++.
Right.
I know that people say, hey, let's write this in Python or whatever, but what I've been using is LVMM. And it's funny, what I do is I can compile it. I should cross compile it, but I use Xcode on the Mac. In fact, I have an old version of Mac OS. I won't bounce to the latest versions right now. I just have too much problem with all the garbage that's on there. But I use a similar compiler to what Xcode does, and it's just C++ for most of the work. And when I have enough of it working, I just sort of get the thing over to, or SCP it, depending on how you want to do it, over to the Raspberry Pi, and I'll compile it again there. Now, I just don't know enough about being successful in cross compiling. If that would be better, certainly, but ultimately you want to compile on the device. Now with the zeros, it's a problem because they're really slow. But this car project is going to be a full RP4, because I need the USB. So yeah, it's C++, and the apps on the phone are Swift, because that's what Apple does now. You can write it. I actually have been successful in getting Swift to compile on the Raspberry Pis, but I don't know. I'm an old, and plus is fine.
Yeah, I think it's kind of a personal choice a lot of times, isn't it? And you've had any reliability issues, like things that fail, like through the operating system, or is it everything works?
So you mean like a watchdog stuff?
Yeah, you obviously have some pretty critical things going on there in some of your projects.
Yeah. So I've tried to minimize, like I've tried to cut. It's funny because you start playing with the Raspberry Pis and you load all this stuff. So I cut out a lot of stuff before I build it, before I actually put it outside. So I kill a lot of the ports. You have to play this game with the Wi-Fi, where it wants to do power management, so you have to shut the power management off. But if you're talking about doing a watchdog, I haven't gotten into that yet. I suppose we should do that. I mean, I'm open to any advice anyone has for me on that.
Yeah, someone did present a watchdog they were using a while ago.
And my question is, somebody said Python for them, and I'm like, I don't have anything against that. The only reason I've been doing C is because I've been able to hit things at a lower level, and rather than have to write a wrapper around something to get to that device or depend on someone's library. A lot of what, for example, the I2C stuff, I'm using standard Linux APIs, but I've written my own I2C. So I use the SMB. Is it SMB? Whatever the Linux API is for that, and so I can hit it at a fairly low level. And it's interesting because you'll see the problems with it, right? Like you can see the noise on the I2C bus with those APIs. You'll see the errors. And so whatever you write, you kind of have to treat it like process control and say, okay, if I get an error, how do I recover this and walk it back? Yeah.
Right, but you haven't seen anything from the OS at all. It's sort of the Linux has been solid. You haven't.
Yeah, it has. I mean,
computer.
you have to do the right stuff. And again, I'm learning. Google is your friend on this case. You have to go out and read everything that's out there, and there's so much garbage. So one of the reasons I did the Substack, notes, is because there's a lot of material that other people have written about, but it's cut and paste stuff from from asking questions on the internet, and often, it's that joke about how do people write code today? They Google it, and so I've had to determine what works and what doesn't work. You can, naturally, my biggest fear are these stupid SSD, these stupid little cards, and these things here. And what sucks about these, that they break. I mean, not just the fact that you overwrite them, but they're physically fragile sometimes too. And I think that's a downside. I've seen people do things better, and maybe that there's a better solution for that. Certainly, you need to shut off the writing logs to the card. And unfortunately, my well pump is writing logs all the time. So what I've done is I've had, again, eventually you're going to burn out those SSDs, but I guess, it's got a limited life. It's got a lifetime. Interestingly enough, my first experience with that was when I worked at PGP. I was a core crypto engineer for PGP, and one of the projects was wiping disks, and the SSD drive started showing up. And so, the answer there is you don't wipe an SSD because it just moves it to another block. In fact, you don't even wipe most modern disks anymore. Just write your stuff encrypted.
Right.
Yeah.
There's a few questions in the chat.
Oh yeah. Let's see, what do you got here? It's hard for me to see what the questions are. Where are they? Is it the top or the bottom? Okay. So why don't you tell me if I can't see it here, if there's a question. Oh, ham regulations. Oh, yeah, sure. In the United States, there are no regulations for scanning frequencies. I suspect there might be in other places, but what's interesting is most of the frequencies are unencrypted. There are people that do encrypted frequencies and stuff, but I'll tell you, if you go out and you get something like SDR, okay, so I'm going to start writing about SDR, but I'll tell you, it's fascinating. If you look in the whole software to find radio stuff, and these little RTL devices, they're like $30. They're amazing. And you get this little app, you'll get an app that's out there, and it will display the spectrum. So this is a talk on its own about these little boxes. But these things are just incredible. It's as the stuff that I knew about digital signal processing in college. It's like I slept and then I woke up and then all this technology jumped ahead. And this was the kind of stuff that we found on Raytheon, on aircraft. And now it's like in these little boxes. So pretty far out.
Pretty amazing. So Sophie was asking about, can we here see the gate security system? I'm not sure if that... You still there?
Yeah, Starlink. Yeah, I'm still here. What are you asking about?
Sorry, Sophie, there's a question just above the last one you read out there. Can we here see the gate security system?
Gate security system. Do you mean the cameras, or do you mean the chicken gate? That's what I'm trying to understand.
Not sure, Sophie.
Oh, okay. So the cameras. Yeah, I can say something about that. The main gate to your house. Yeah, that's a whole other story. I live in a very rural area. There's no gate. You have to come up a long driveway and find your way up here. And so right now, I don't particularly need a gate. Yeah, I'm in the U.S. And it might be a little difficult for you folks out there, but my gate is my gate is typically an AR-15, so so yeah, sorry, it's different culture, but and I'm not kidding you. There's enough people in Oregon who are armed that people don't do home invasions. But the cameras are there because a couple of things. One, I would have a problem with bears, where I have more problem with four-legged creatures. So I have problems with bears coming in and knocking over the trash cans. So I have an app. This is called, and I haven't done it myself. It's called X. I'm going to pronounce it. Xeoma, Xeoma. All right, and it runs on the Raspberry Pis. And if you click on it, it shows you, the cameras. Let me see if I can. Oh, you know what? I might be able to bring the cameras up. There's a chance. I don't know if I can show the screen. Let's just see. Maybe it's possible. Sure. Okay. So I'm going to see if Zoom will let me show the entire screen. Whiteboard, iPhone, desktop. All right. So here is all of the cameras at the same time. It's kind of a mess. It's on my desktop. But, I can take a particular thing, like here's the chickens, and say, let's zoom in and see what's going on. Well, there's nothing going on there right now. Or, go check on the driveway, or the vehicle or whatever. And let's see if I can quit this thing, because this takes over my entire screen. There's too many. So those are the cameras, but there's RPI software that will dump the video. Yeah, the reason there's so many cameras is that, again, it was about the bears, and I wanted to record and see, was the bear knocking over the garbage can? What predator do I have to deal with this week for the chickens and stuff? So that's really what that's about. And this is asking about OpenCV. I don't know what that is, but it sounds interesting.
It's computer vision, open computer vision.
To actually look at, I don't know what that is. I won't look it up.
It sort of recognizes objects and stuff.
Yeah, no, I don't care. All I really want to do was just record like what's on my front porch, just so I can see. I had two goals. One, I wanted to record what was on my front porch, so if I could see if there were raccoons or stuff coming in and bothering the cats and the dogs. And the other was really on occasion when I have a vehicle come into the driveway, and often they're just lost. You come out and say, hey, where are you going? Whatever, and they're pretty good about that. But sometimes I've had these real estate people come up and try to look at property, and I just want to get their license plates. That is Ethernet for all of the cameras. And the only reason that is that we're power over Ethernet. So yeah, there's that. The CAN interface.
Yeah, the CAN interface. Yes.
Okay, so there's two CAN interfaces up there. I am a fan of the WaveShare CAN interface, and the WaveShare 2 CAN hats. There's other guys out there. There's a PyCan guy, but I got to tell you, for whatever this is, like $20, $30, this is a great little device. I love the fact that they did a physical separation between the two, and a little isolator, so that the voltage problems aren't, because cars have really dirty voltage and you have all kinds of problems. So I like that they did that. I've been talking 500 megahertz and 128 megahertz, and it hasn't been a problem. Yeah. So and honestly, there's enough. The great thing about, and I've written about this, about CAN, I got about 5 articles in this. The great thing about the CAN stuff is it's fairly well documented. Now, I'm just saying this really fast. There's the CAN bus that's internally, and the computers talking to each other. And then there's the ODB. And there's a slight distinction between the two, but the same hardware can talk to both of them. Basically, one is a bigger protocol on top of the other.
Cool. We have one last question from anyone. People can unmute themselves if they need to. They want.
Do I have a Twitter handle? I am not on Twitter. I am on, yeah. So my articles on CAN are on Substack. Everything is on Substack. And I am called Vin the Wrench on Substack. So if you just go to Substack, Vin the Wrench, everything is out there. Oh, that went to you, Richard. That should go to everybody. Hang on. Oh my gosh. All right. There you go. Vin the Wrench. I think I can find it, but oh gosh, let me find. Oh, here. There you go. Sorry. Yeah, everything's up there. And I've written all about the can and about the others, pretty much all the projects. And there's links to all the other stuff that's really cool.
Cool. Great. Thanks very much. That was very good.
Oh, how much megabyte is an hour video? I don't know. I kill off I recycle it. I recycle the video stuff.
Lots of different projects you got going on there.
Yeah.
Great. Thanks very much. It's very
Thank
good.
you, guys.
I will produce a video at some point, but cut out certain bits. We'll say that.
Yeah.
Thanks very much.
Listen, I'll just say I'm grateful to you folks. I am dying to come across other folks who are doing Raspberry Pi stuff. I mean, it's really useful for us to have a community. So I'm really grateful for you guys to invite me to this. And,
yeah.
It's
great to hang out.
Yeah.
Hope you can join us again soon. Of course, we're going to stay for the rest. Let's see. Great. Thanks.